skočí.
Čeká se ještě vysmrkám, ještě to nepouště.
Už to je, už jsme online,
Jsme naživo.
Hello out there in the world of online reality. I hope that you're healthy and safe, that you are keeping your minds, your virus appearance positive. My name is Jarda Machaň. Maybe you know me also as Moza or Fukesh. Usually the guys from Kebula knows me like that. And I'm the Chief Customer Officer in Revolgy. And I'm getting used to moderate these online meetups. But I'm still heavily looking forward to meeting you all in the real world again, hopefully as soon as possible, because I really miss the physical contact with you guys. And a year is a really long time to be locked down. So let me thank all the great guests and you, especially you, the participants of this 15th Cloud Native Meetup Prague. Thanks for coming, because without you, this activity won't have much sense. I'd also like to thank Revolgy and the great team led by Terka Grill, who organizes this great meetup, and also Marek Bartík from Pipetail, who brought our great speakers, which will speak tonight. And let's have a look on who they are. The first speaker will be Láďa Prskavec from Apiary. And the second guy will be Ondra Hlaváček. Maybe you can also know him as Nyloš or Nyler. And you can listen to them at Radio 1 because he's also a great DJ. And he is from Kebula, our friends. And we also be neighbors with Nyloš soon in Liberec, the great city in the northern of Bohemia. Please, during the talks, ask your questions in the chat. And we'd also appreciate a lot if you can provide us with your feedback. It's super important for us because it's the ultimate source of learnings and the way how to improve this meetup. So use our channels for that. So please follow us at meetup.com and twitter.com/cloudnativeprague. Let me also point out that we are super happy to have you here tonight, that you come, although we can't meet in a pub or some meetup space and have a beer and fried cheese or something like that together. But therefore, we definitely all can look forward even more to one of the next meetups, which will definitely, I hope, happen outside the online world and with a glass of a proper beer. So let's have a look on our first speaker. Let me introduce him. This is Láďa Prskavec. His main focus of work is site reliability engineering. And Láďa will talk about developing services in Oracle Cloud Infrastructure. So stage is yours, Láďa.
Thanks. And I will share my slides. Hi, everyone. Welcome on my talk. I'm Ladislav. I will make short overview how we build cloud in Oracle. Why Oracle doing Oracle Cloud? There are many other clouds, you know, AWS, Azure, Google Cloud. Why Oracle needs one more? The main reason for that is that we have Oracle database. I think that you know Oracle database that exists more than 30 years. And we have big amount of customers they using Oracle database. Still, cloud adoption is low. It's about 15%, and many our customers are still on on-premise data centers, and they won't migrate to cloud, but it's not easy task for them, and we try help them. And it's not just about database, but if you want make something as SQL database, Oracle of cloud friendly, cloud native, it's important to work on many layers. One is the database itself as software, but second layer is infrastructure. And that's why Oracle building Oracle Cloud, that we have all control from network, infrastructure, and database, and we can create solutions for customers they need it. And that's why we building our cloud. We have currently about 29 regions. We have 22 commercial region. We have 7 for government. And we have all that features that normal cloud as AWS Azure have. We have compliance for governments. We support FedRAMP, GDPR, HIPAA, other things. We also support one thing that it's important for our customers. They have usually on-premise data centers, and that's L2 network virtualization. That helps customers migrate data centers as it is with, for example, VMware networks. And it's something that is advantage for Oracle. That's AWS have L3 network virtualization, and we listen customers and try help them with that migration. That's not easy, and we hard working on improve the solutions that we support them. Our cloud services, including infrastructure as service, including platform as service, and including software as service too. That's a big amount of application that we support many industries on all levels with different type of software. For example, you can know, for example, CRM NetSuite that is based in Prague, and other things that Oracle offered. Our OCI, the Oracle Cloud Infrastructure, have solutions for customers that you can choose how you want make your deployments, or that offering that is provided by Oracle. We offer the public cloud. That's the normal one that we support customers as every other cloud, but we have a specific solution called Cloud at Customer. That's usually a region that is dedicated to customer. We can put our region in their data centers, and they have all that support from us. We manage for them. We provide all services that are available in public cloud directly to customers for the same price as public cloud. And we just cooperate with, for example, Microsoft Azure in SaaS services that if you need hybrid cloud between two cloud, Oracle and Azure, we have special solutions with Azure on 6 different locations around the world that we can make that hybrid cloud if you need 2 public clouds available for you. And third option that you can have is a Rover Edge. It's edge solution that we provide, that you have a whole cloud in these small computers. You take 5 of them to 15 of them and make own region everywhere on the planet without needed access to internet. For example, if you're running Arctic expedition, you can do it with this. You can run infrastructure on some oil towers somewhere on ocean, no problem. We support it. And now I will focus on our team in Prague more. And we are one of service group of services in OCI. Our engineering director is located in Bristol in UK, and we have four teams. One is OCI API Gateway. That's we have engineering teams split between United Kingdom, India, and Prague. We have Oracle Functions teams that is very similar to AWS Lambda service. We have API Platform and API Cloud Service. That is my team in Prague now. In Prague, also we have a guy who working in OCI logging team. That is one of core services of OCI. And now how we work, how we organize teams in OCI. Oh, sorry. We are split into service teams. Service team oriented architecture is that every team have own service, as for example API or OCI API gateway, and that team have full ownership of service. We make deployments, we care about security, compliance, region builds, and on-calls, and all development around the service. We using quite standard technologies. You can see that we use Java, Go, Python, TypeScript with React for front end. We use Git. Our APIs are in open API specification. We use Jira. We use Slack for communication. In operations world, we use Terraform. We use Grafana. We use Kubernetes. We use GraalVM, Jira SD, PagerDuty, and many internal tools. As developer, you have to build the service first, and as operator role, you have to deploy that service or manage. And we doing everything with focus on security on first place, that we try be secure as possible, that we working on solution that that works for us in that way, that we know that the supply chain is secure and we cannot get issue, for example, as SolarWinds get in last year, that one can use your software to inject your customers. That's why, for example, our developers have to work. We use YubiKeys for authentication, and you develop service. You use some version control. We use Bitbucket here. You put that software there. You run build service that create artifact, usually Docker image that will be put into Artifactory that's used later for deployments by operators. And as you see, that build service doesn't have access to internet. That's quite important. Our build service, that if we building service, running tests and all the things, is without accessing directly to internet. You have to download all your dependencies via Artifactory. It's created directly there with some upstream, downstream projects, or is proxy through the Artifactory, for example, for NPM public registry or something else. That's why this chain is protected by some security scanning on every level. That we have scanners on that Artifactory repository for automatic scanning for all dependencies. We have similar scanners for version control systems, that we prevent any leaking some credentials or similar things that you see on GitHub. We have internally in our repositories and too. That's quite standard. And if you are a developer, you are done with pushing into that Artifactory, and that's one thing. But you have to change your head that you are operator too for public regions. But why I separate that role is that operators are part of team, but we have special operators that are for some specific type of regions, usually for that clouded customer regions, or some regions that are run by government, and you need clearance for make operations there. And as you can see that biggest challenge that make our work interesting is deploying to that 30 regions around the world, and it's a very hard engineering task, and we adding new regions every year, and we have to work on automating everything, region builds and deployment in everyday work. And you see that, for example, how we deploy usually is done is that we use orchestrator service that's based on Terraform. It's our service that they use Terraform. You write Terraform files, but we have own providers and some more more features there, that you make some workflow for deployment. Usually you deploy first into some small region that have one availability domain. It's similar to availability zone in AWS. And after you are there, no alarms, no issues with metrics, you deploy in some 3AD region, some bigger as Frankfurt or Ashburn or Phoenix. And if it's there done, you deploy all the rest of regions that are needed. That's usually others. And there are some specific regions that you have to follow some special process. That's usually government type of regions. Yeah. Yeah, and if you want to know more, now is time for questions.
So we have a first question from Daria. How long does it take to deploy a service to all regions? How frequently do you deploy to production layer?
Yeah, that depends on service. Usually, the deploy to all regions take about 2-3 days. Depends on some conditions. We have that public one that's usually 2-3 days, depends how fast it is, and there's some delay usually. The rest of week are waiting for some conditions to deploy that isolated regions. There are specific conditions, for example, that you have to deploy only in their work hours on Friday or something. That not sure exactly. It's by customer agreements. And how frequently we deploy? We can deploy usually as we need it. We usually try make deploys every week, and the mandatory deploy is every month. That every service have to be deployed, every service, at least one per month by security patching and OS patching process, that we ensure that all applications are secure on latest versions of operation system and all the things. But yeah, we can deploy as we need it. It depends how service team automate all testing and all the procedures.
Thank you. And we have one more question from Daria. How do you monitor services running in all regions?
Yeah, we have a set of monitoring. We have own logging service that's collecting log. Is similar what people know as Elk, but we have own solution. They are more scalable than classic Elk solution. We use Grafana for our dashboards. And we have own metric solution that's usually plugin for Grafana that you can use in Grafana, and you can find Oracle Cloud Infrastructure plugin for Grafana. If you are a customer, you can use our public monitoring in your Grafana. It's available, yeah, that's all. We don't have tracing service yet. We make all requests are by IDs, but we don't have now solution for traces. But I think that's a matter of time that in logs all information are there. Just need some solution that are scalable for that big amount of data that we're getting.
Thanks, Lai. I have one more question from my side, a more general one. If you talk with the customers, do they mention any advantages why they choose Oracle over other public cloud providers like AWS or Google?
Yeah, there are a few things they like it, and one is that we are much more similar to data centers. For example, if you can use MAC addresses for addressing. That's what I told about L2 virtualization network. Yeah, that you cannot use in AWS and others. They have L3. The second thing, if we we told you in documentation that's 25 gigabits per second between instances. It's minimal value. It's not that you are run of IO credits or network credits on AWS. We guarantee that bandwidth for you. And that's much more easiest for people think. There are in very similar situation as own data centers. Yeah, that we try simplify this, that you don't need predicted how many consumption you have and all the things. And we have big advantage that we have quite newest hardware using. We have bare metal machines if you need it, not just virtualization. And the performance is one thing that they like it. It's usually much more better than others clouds for reasonable price.
Thank you. And one more question from my side is, I can see on the slide you share with us on the world map that you have dedicated government data centers. So can you see a huge adoption of, let's say, public, let's say, customers like governments? And
that's quite different. I forgot on that, but in Oracle usually have these customers for years. Yeah, we usually working, I think, 200 countries or something that with customers, and we just help them to use for cloud. For example, we have regions for United States government, us Google, us AWS, us Azure, the others cloud. We have government regions for UK government dedicated. And for example, Oman government using us. They have clouded customer solution directly from us on their country. That's quite, you see that we have many regions, and usually trying be in every country there are some important customers, and they are already our customers. We support them with that we creating regions in their area and other things, that we have not so big regions as, for example, AWS, but we are more focused, be in every important country. We trying be more where are already our customers, to support them to go to cloud and help them with that. That's quite still not easy for big enterprise customers.
That's absolutely true. So thanks a lot for a great deep dive, Vladio. And now let me bring our second guest, who is Niloš Ondra Hlaváček, who is a site reliability engineer in Kebula. And Ondra will share his story on how they moved from self-hosted to cloud-hosted release pipelines there in Kebula. So Nilo, the stage is yours, man.
Hi, everyone. Thanks, Vladio, for your very interesting talk. It was really enlightening. Thanks for the stage. This is my first time doing an online talk, so please bear with me. That's the first time experience. Let me share the screen and let's see if it works. I hope it's up. Yeah, it's there. So I'm Ondřej Hlaváček, as Moza introduced me. I'm a site reliability engineer at Kebula. I've been working in Kebula for as long as I can remember. It's really like 11 or 12 years now, I think. And I love traveling. 9 years ago, I moved to Vancouver, Canada, and helped Milan Veverka, one of our co-founders, start our first office in North America. We started in his basement, then we rented the first office, hired first people, and after a year or so, I moved again, and since then, I never stopped working remotely. I am lucky enough that Kebula has remote work in its DNA and gives me the freedom to travel. That was before kids and before coronavirus. Or I can live close to the nature outside big cities. So I consider myself very lucky working for Kebula. For those who don't know Kebula, we're developing a software that we call a data operations platform. It's a tool for working with data in one place as a serverless platform. Serverless platform from the customer's point of view. The customer doesn't know any hardware specifications. He doesn't really care about what machines is running on. He just creates the workload and we process it. It's completely serverless from their point of view, not from ours. So it's data ingestion, cleaning, auditing, schedulers, machine learning, you name it, it's all there, and you can try it for free. My talk tonight will have two parts. In the first part, I will cover the CI/CD history in Kabula, how we moved from between various tools that we used and what were the motives and drawbacks of each of the solutions. And at the end, I will add 5 random tips for Azure DevOps and releasing to Azure Cloud. So let's start. Oh, here's a few funny pictures. That's me redecorating the Vancouver office 9 years ago, and that's me, my wife, and our son Mateas. This year in winter, we are very happy that we live close to nature. So even with the lockdown today, we are still able to get outside and get to some snow. So yeah, it's amazing, and I feel pretty bad for all of you that can't do that. So at Kabula, we try to have no operations team. So far, so good. We don't have an operations team. We focus on hosted and managed services. That allows us to grow faster, try new technologies. It allows us to limit the knowledge we have to maintain the whole stack. With this, even without the operations team, we are still able to maintain 24/7 support. Actually, we started our first 24/7, like the real 24/7 with pagers and everything yesterday, and no incident so far. And I am not on call right now, so I can't be bugged. So it's someone else's turn tonight. So let's go back to history. Let's roll back the time machine. We started with Jenkins. We installed it on one of our servers. It was free. It was easy to install. Just a couple packages, then some plugins, extensions. And we thought, okay, that's great. Requires almost no maintenance. At least we thought at the time. Requires no in-house skills. We got some pipelines in there, deploys, tests, everything. It was fine until one day we realized our Jenkins instance got hacked. Lucky for us, it was just a malware that was trying to mine some Bitcoins. So we deleted that. We changed all our passwords and tokens, installed the latest security updates, and decided that Jenkins is a not good solution for us. We are really bad at maintaining software. As I told in the previous slide, we try to get as many services as we can. So it was time to move on. The next step was Travis CI. It was great at the time. We had around 500 public repositories, and we can run them all for free. It's pretty amazing. It's cool. Big workload, no expenses. We had around 5 core repositories that were private, but it's not a big issue financial wise. But in the last 12 months, maybe even more, we are having some significant performance issues with Travis CI. So we started moving towards their paid tier, but it showed up that it's not great either. We are having issues with support. We submit a bug report to them, like very serious stuff, and we get a response in a month, maybe 2 months. So it's not really good for us. And even when paying for Travis CI, we still have performance issues. So we started thinking, okay, it's time to move on again. Meanwhile, we started talking to corporate clients, financial sector. So it's a big deal for us that we were talking to small businesses before, but financial sector has a completely different set of requirements. And even when you sell them software as a service, we still have to comply with some of their internal policies. So public repositories is just a hassle to explain why this repository has to be public, why it can be private, security perspective, and so on. So that will show up on the Travis CI bill when we move all the repositories to private. And its Travis CI is still unreliable. There are still bugs, performance issues, and so on. Then some of the clients, they require to install the platform into their private cloud network, or maybe even partly on the on-prem. I really can't imagine explaining some security guy in a financial sector, in a corporate in a financial sector, that we need to install their GitLab runner. Like that's to completely foreign piece of software for them, and making them work for us. So like third-party open source tools, that's a big issue as well. Then governance, everything, you have to log everything, you have to integrate everything with the client monitoring systems. So that is a must. Meanwhile, even before finishing talks with the corporate clients, we started trying out Azure DevOps. It is still relatively young, still evolving. But it has strong background from previous Microsoft services, TFS and VSTS, which is, I believe, I don't know these acronyms. It's Teams Foundation Service and Visual Studio Team Services. I don't know what it stands for. I don't know the history, but sometimes it pops up in the UI. But as a software, Azure DevOps looks pretty young, looks pretty neat, looks pretty okay. Of course, it covers the whole development stack, agile boards, repositories, artifact stores, documentation, and also CI/CD pipelines. It scales pretty well. You just pay for more than one parallel process. So one parallel process is there for free, and you pay $40 a month for more than one for each parallel job that above one. And you can also install self-hosted agents. More on that a little later. But the scalability is just you click on the change on the button, the change button here, and you scale it up, and it shows up on the bill next month. So it's fairly easy. No, you don't need to run any virtual machines, anything. It just runs. It ticks many checkboxes on the corporate feature list. You can encrypt the secrets using customers' encryption key. So if you need to store any secrets in the pipeline, it can be encrypted using the customer's encryption key. That's a pretty big deal. Then it also has all the government and access management features because it's integrated with Azure Active Directory, and then it can integrate with almost all major stuff that's out there. Also, for a company with history like Microsoft, it integrates reasonably well with the ecosystem outside of Microsoft. So you're not locked in with Microsoft services only. You can deploy and use stuff from AWS and any other vendor that's out there. It's pretty open, and I think it's one of their goals to keep it open, to not have people locked down on Azure. And what is a big benefit for us is that Microsoft helps us advocate using their technologies with the clients we have. That means that if we need to install the self-hosted agent on clients on-prem, on clients' private cloud infrastructure, Microsoft is there to help us advocate and explain the customer what are all the security aspects of using that software, and helps us deploy the software there. So that's a big help, because we as a small company we have limited power how to explain stuff to the big clients. But when Microsoft is on our side, and they try, if you have good relationships with Microsoft and you pay them certain amount a month, like you have a spend there, they really try to help you with the customers. So Azure DevOps, they have two types of pipelines. They separated build pipelines and release pipelines for various reasons. I quite like this approach. One of the big differences today between build and release pipelines is that you can store build pipelines as YAML files in your repository. So that's the same with all the major tools out there. You just have the repository, you have the pipeline definition in your repository, and the pipeline is generated from there. The release pipelines do not have that feature right now. I believe Microsoft is actively working on that, but I've been working with Azure DevOps for a year and a half, maybe 2 years now, and there was no significant improvement. So that's one of the major drawbacks, that you cannot store the release pipeline in your repository. You have to do everything in the UI. So that also changes the way how we approach the release pipelines. And you will see that in the tips, how to make your life easier, even when you have to click the stuff in the UI. The screenshot on the bottom screenshot shows how the release pipeline looks like. You can define stages. The left box is a testing stage, and then you can define like production stages that follow after the testing stage. So you can, for example, set up a manual or automatic gate. So that means that if you deploy your application to the testing environment, there can be a manual or automatic check. Automatic check is usually just an HTTP request. A manual check is a notification that someone arrives in his mailbox, he goes, performs some action, and clicks on the button, okay, this release is approved. And then the deploy to the other stages follows automatically and is parallelized. Also, the difference between build and release pipelines is that they use different triggers. For example, the release pipeline is triggered by new artifacts or new images in your repository, and you don't need that feature in the build pipeline. The build pipeline usually ends up with uploading the artifacts to a repository, being just a blob storage or an image registry. And then there's a separate pipeline, the release pipeline takes it from there. That also means that if you need to roll back, you don't have to mess up with your build pipeline. You just run the release pipeline separately and roll back the last release or couple of releases or whatever. And we do it quite regularly, and it works. So that was about our history with Azure DevOps. We went from Jenkins, we got hacked. We went then to Travis CI, and now we're on Azure DevOps, and we deploy both infrastructure and the services using DevOps. So even our infrastructure is deployed in Azure DevOps. In the next few minutes, I will add just 5 random tips how to make your life easier with Azure DevOps and for deploying infrastructure on Azure. So let's start with the first one. It just goes to the basics. Try to make simple scripts. When I started building the Azure infrastructure, I did not know any Terraform. So sorry for that. I apologize for all the Terraform geeks out there. I wrote everything using ARM templates and Bash scripts. That was my tool set. That was something I was comfortable with, and I could make it work. So I wrote small script. This is like 13 lines of code that deploys a key vault. That's like this script deploys a key vault, and in fact it could be just a one-liner, but I want to make it readable, so it's 13 lines. And this script is then used in the pipeline. So my point of this slide is use the tools you have and adopt your pipelines to your project. Do not try to adopt or change your project to suit a new fancy tooling you have. Just try to use what you need or what you know, what you're comfortable with, and go from there. And then when I had these small scripts and ARM templates, they were all stored on GitHub, so I can call this infrastructure as code. On the right side, you can see a screenshot from the GitHub repository when we have the whole infrastructure stack, and it's like around 25, maybe 30 Bash scripts. Some of the Bash scripts are simple, as in the previous slide. Just get a variable, put it into or pass it to an ARM template and deploy it. So that's the best approach. Is more or less declarative. And then in some cases you have to do some manual work because ARM template does not support that. So then it's just the Azure CLI or kubectl commands, and that's an imperative approach. But it's still all stored in the repository. It's versioned. You can make pull requests. You can roll back to the previous state of the repository. So it's still better than nothing. So for our Azure deployment, we use ARM templates orchestrated in Bash scripts. And currently we're reinventing the same thing in AWS, and we decided that we want to go with Terraform. So that's like generation 2 of the infrastructure deployment. And I hope after we finish this, we should be able to get rid of my ugly Bash scripts for Azure and replace it with Terraform as well. And there's one thing, but I will mention it on the next slide. Excuse me. So Azure DevOps is a visual tool. On the picture here, you can see a task, a kubectl task. It has so many checkboxes, so many input boxes, so many options and drop downs and collapsible sections. Oh, it's so tempting to use, but it has limited powers. It's a pain to maintain. Once you fill this up and then you replicate and duplicate it to multiple stages and multiple release pipelines, you will get lost. Imagine you have this task in 5 stages. You have 5 environments, so you deploy. You use the same sequence of steps or sequence of tasks in 5 environments, and you have, let's say, 5 other pipelines, similar pipelines. And then you need to change a namespace of a kubectl deployment. You need to go through 25 tasks I would not be able to do it. I would probably delete the whole infrastructure by making a stupid mistake there. It's not good. I don't like it. First, the logic is not captured in code. It's replicated in so many places. So many places I'm sure I will mess up. Then if you need to change something, you change it at many places and you will end up with a big mess. So, and also, it does not run locally. If you need to debug this kubectl command, there is no way you can do it in the pipeline. So back to one of the previous slides, I wrapped everything in simple bash scripts that are tool agnostic. They are simple enough with just simple error control. And then I run these bash scripts as tasks in the pipeline. So I don't have to worry about all the options there of the kubectl command. They are stored in the repository. And I can change them all in just one place. I will go back to the previous slide. So imagine there's 25 of these bash scripts as 25 tasks in the pipeline. Oh, it's a mess again. So what we created is that one of these scripts here on this slide is just an orchestration script that runs these other 25 scripts as a sequence. And that one single script, which its only purpose is to run the correct order of the other scripts, is then executed in the pipeline. So the pipeline, the release pipeline, is fairly simple. It's just install Azure CLI, log into Azure, and then run this orchestration script. And that's it. That's the whole pipeline. Everything else is stored in GitHub in the repository. So even if you change the order of the sequence of the steps, you change it in the repository. It's a pull request. So that's our approach to it. So let's drift away from DevOps a little bit and deep dive into internals of Azure. Dynamic resource names and IDs. Oh, that's a mess. Every resource has a different policy on name uniqueness. That means that, for example, a storage account has to have a globally unique name. A Key Vault has to have a globally for all customers in all regions, everywhere in the world. You can't reuse it. And if you, for example, if you deploy something and you use an already used name by someone else, the deployment just fails. So you have to change the name and blah, 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 and so on. And for example, a Key Vault has the same uniqueness constraint as a storage account. It has to be globally unique, but it also has to be under 21 characters. And then, for example, a MySQL database has to be unique in a region. And then other resource has to be unique in your subscription or in your resource group. It's just a mess. It's like really difficult to navigate, really difficult to figure out. So be prepared to have naming conventions and enforce them. What we did is that we have a parameter called Kabula stack, which is a unique identifier of each stack, of each instance of the platform. And we pass it to every template, every ARM template that's out there. And then we hash it using the unique string function and concatenate it to the resource name. So in this case, it's a Kubernetes cluster, a managed Kubernetes cluster with a suffix that represents the stack. So that's our approach. CloudFormation in AWS does this automatically, of course. ARM and Azure does not, so you have to deal with stuff like this. If you did not have enough, there's one more tip, and that's something you may want to do intuitively, but it's really not a good idea. For example, imagine a situation that you want to create or deploy a new database, and then use the password somewhere else or later in the code. So ARM templates and Azure deployments, they require that you pass the password to the template and have the password ready from the beginning. So you create a password, then you create a database with the password, and then you have to pass the password to some other tasks in the pipeline, a script later or two scripts later, and use the password for your initial database migration, because it's somewhere else. It might want other resources or might have some weird dependencies. So you can use this echo double quote hashbang VSO and then function name, so to pass to pass a value from your script. So basically, what the bash script does is echoes this on the standard output. Azure DevOps automatically catches this this magic word, hides it from the logging outputs, and sets a variable called testvar and sets its value to test value. Sounds pretty good. It's pretty difficult to implement, actually. I tried like 10 times before I was able to implement it properly. Maybe I'm so bad at bash and I'm so bad at doing this, but it was not really straightforward. Maybe there was a bug and they fixed it. I don't really know. But I still think it's a bad idea because it creates a dependency. So you need to know, basically it creates a dependency. So before you run the database migration, you need to know that you have to run the script with the database initialization that will store the variable in the environment. So it's not a good idea because the more variables you pass, the more complex the graph gets, and then you will get lost. So how to solve this? So you can either read it directly from the resource. So that's not the case of the password, but for example, the database identifier, and you need to figure out the host name or the IP address. So you can just ask the database, the database resource in your cloud provider. That is the case, for example, line 13 to line 17. I am getting an IP address from a kubectl service that I will use later in the bash. Just ask the cluster to give me the IP address, and I will store it locally in the script, and I will not pass it to any other script. Also, you can use external storage. Template outputs is the easiest way that applies to both ARM templates and CloudFormation templates. There's a field for output. So if you create a database, when the deployment is ready and finished in Azure and in AWS, you can fill the output fields of the template or of the deployment with certain values. So for example, if you need to know the hosting of the database, you can store it in the output of the template or the deployment. That's the case of line number 4 to 8, where I just read a value cluster name on line 8 from a deployment called KBC AKS. So the cluster name is basically this cluster name from the previous slide, KBC-AKS- some hash. So I can read it, so I don't have to figure it out, recreate. I just read it from the template output, store there. And what to do about the password? You can use the secure storage. So the situation goes then like create a password, create a database with the password, and store the password in a secure storage. In Azure, it's Key Vault. So you store it in the Key Vault, and then in a completely different universe, in a completely different task, in a completely different pipeline, you can read the password securely from the storage. So there's no dependency. You can run all these scripts locally, you can debug them, figure out what's wrong, and you don't have this tight coupling between tasks. So that's our approach. So I believe that was all from me. If you have any questions, I think it's time to answer them now, and then you can follow us at 500.kabula.com. That's our tech developers blog post.
Thanks, Nyla, for a great and almost hands-on demo and talk covering your history and those nice tips. We have one question here from audience, from Stepan Rani. Usually, it's a huge headache to work with integrations to other services like AWS, Git repos, etc. Does Azure DevOps come with some tooling for managing such connections?
Yes, there's a section called service connections, and you can define all your connections that your pipelines will require on an organization or project level, and then you can share them between organizations and projects. So you can keep them centralized, and also there's a security feature that someone can define these connections, and the others, for example, if there's an admin and there are just the developers cannot modify it and read it. They can just use it in a pipeline, or you can just change the scope of the permissions that they can't even use them in a different pipeline. It's only where the admin set it to be used. So I believe that answer the question. There are many service connections for many services, and it works for us, even outside the Azure ecosystem.
Thanks. We have one more from Marek. You mentioned having one bash script that orchestrates everything and runs sequentially the other scripts in a given order. Does this make it slow? Is it a trade-off for running everything locally?
Yes, it is slow, but maybe, yeah, there's a way. Terraform is the way out of this. So it creates the drift or creates the diff of the desired state, and it just applies the modifications. I believe CloudFormation templates work that way natively, so you don't have to have any other tooling. Azure, unfortunately, does not do that. But for our stack, it's not that crucial, or the time is not that critical. The whole infrastructure, when it's deployed, the release pipeline that deploys a couple of times a day, that deploys or redeploys or changes or modifies the infrastructure, runs for 30 minutes per stack. And if you have 5 production environments and they run all in parallel, then it's 30 minutes and it's deployed. So it is slow, but it's not a deal breaker at this moment. And we're looking forward to adopting Terraform that will help us reduce these times even slower, like even lower.
Thanks. Hope that answers the questions. We don't have any other questions in the chat right now, so I have one more, let's say, high level from my side. So, Nailo, have you somehow measured how much did the migration to the Azure DevOps improve your performance or peace of mind regarding the support in comparison to Travis or Jenkins?
For the infrastructure part, we did not have automated infrastructure deployment before we started working with Azure DevOps. So we wanted to have automated infrastructure deployment, so we started directly with Azure DevOps. And for the others, we are still having some pipelines in Travis CI, and we are slowly migrating them all to Azure DevOps. So I don't have the numbers, but I know that the bugs we had on Travis CI were pretty severe, and Azure support compared to Travis CI support is just another level. Like Travis, and I'm not telling that Azure support is great. It's just that our experience with Travis CI is so bad that and there was no help. There was no hope, so we had to move somewhere else.
Cool, thanks. One more from my side is I understand from your wrap up on the beginning of the talk that using Azure DevOps could be a door opener to the big corporations, which are usually quite difficult to have a discussion with. Is it right?
It can be. It depends on your relationship with Microsoft. And that applies to all the big cloud vendors and cloud players. So it might be the same case with Oracle Cloud. So if you have a good relationship with Oracle Cloud, I'm pretty sure that they will help us open the door with your customers, because it means cash for them. So just keep the good relationships with your cloud vendors and they will help you. I hope.
We all do. Thank you. We don't have any other questions, so let me wrap it up. And yes, this is it. So we are on the finish line of tonight's meetup. So thank you all out there for joining us tonight, and especially you, our great speakers, Láďa and Ondra. It was a pleasure to have you on board, guys. Thank you, Terka Grill and the whole team to bring this meetup live. And thank you, Revolgy, our company, for powering this great event. We will bring you the next meetup in about a month. So stay tuned on our channels. This is the Meetup.com and the Twitter. And by the way, we are also constantly hiring as Revolgy is growing. So have a look at our website at revolgy.com or the Twitter, or just ping us a message if you'll be interested in having a coffee with us, at least the virtual one, because we cannot still meet in a physical world. And I think it's worth mentioning, when I was listening to Naila and his story about living nearby the nature, that we are also fully remote. So it doesn't matter if you'd like to work from Liberec or, I don't know, Singapore. So it was a pleasure to meet you all tonight, guys, and see you next time. Hopefully with a glass of a beer in a pub on the after party. I hope so. See you guys.
Thanks for having us.
See you.